All right, so the table below lists distances in miles and cheapest airline fares in dollars to certain destinations for passengers flying out of Baltimore, Maryland as of July 8th, 1995. I can assure you those are not the prices anymore. So we have the destination, which isn't exactly relevant exactly for what we're doing, but then we have distance and airfare. So distance is going to be the explanatory variable. And airfare is going to be the response variable. So distance is going to be my L1. Airfare is going to be my L2. So all those need to go into your list. Josh, do you know where your classmates are this class period?
Some of them are in Bible. Some of them are in study hall. For that little PE elective thing.
Okay. Thanks. I was just asked if I had one of your classmates, and I was like, I do not, so.
Just me.
I'm going to check the computer lab because.
That's a lot of eights and dollars.
They'll figure it out on their own, I guess. All right, once you do this, we need to stat, calc, Linreg to get the regression model for predicting airfare and distance. So basically, we're going to have a y hat is equal to b sub 0 plus b1x. And this is our y-intercept and our slope. So I'm going to be obviously doing this for this specific problem. This is just the generic form of it. So I'm going to have airfare hat is equal to, so what did we get for the y-intercept when y'all put it in?
What do you want it rounded to?
2 decimal places, I guess.
You 83.27.
Okay, and then I'm assuming it's a positive value for the slope. All right, what's the slope?
0.12.
And then that'll be times distance, because that would be my x value. Why is this doing this? If that made it better or worse. Okay, so now, what airfare does the least squares regression line predict for a destination which is 900 miles away? So basically, what we're going to do is, in the spot where we have distance, we're going to put in 900 and basically just solve the equation. So we'll have airfare hat is equal to 83.27 plus 0.12 times 900. So airfare hat is equal to $191.27. Can y'all see that okay? Because I feel like it's like hard to read.
Just a tad bit difficult to read.
Let me see if I can make it darker, if that makes it better.
That does make it better.
Did it? Okay. Try to focus it, make sure it's... Is that better?
Yeah, that's good.
Okay. I think because of like the dark like backing that's now on it when I do this, that's why it's harder to read these ones, and so I need to like bring the brightness down. Normally the brightness has to be up for it to be readable, so. Alright. Not that I think you're going to, but don't write anything in this space off to one side or the other, because we're going to come back and write something after we do the next question, or after we do part C. So what airfare would the regression line predict for a flight to San Francisco, which is 2,842 miles, I can read, from Baltimore? Would you take this prediction as seriously as the one for 900 miles? Explain. So I'm going to set it up the same way. Airfare hat is equal to 83.27 plus 0.12 times 2,842, not 200. What did we get?
$124.31.
$424.31. So, would you take this prediction as seriously as the one for 900 miles? It's a yes or no question.
No.
I don't see why not. I say yes, but I don't know why.
Alright, so Josh says no. Peyton says yes.
I just kind of want to see which one's right.
You say yes? Alright. The answer is no. And I'm going to explain why. Okay. This is what we call extrapolation. Big words, I know. So, what's different about this value versus the 900 is that 900 is within our data set, because I had distances as low as, 189 miles, and I also had them as high as 1,216 miles. I think that's, or 1,502. So I had those. But more importantly, I had some in the 900 range, so that one kind of fits within our data. But this 2,842 is over 1,000 miles farther than the next one within our data. Okay, it's about 1,300 more. So this is outside of our data set, which is basically what extrapolation means. So 2,842 is outside the data set. So be cautious. And so I'll underline this. Extrapolation means it is a value outside data set. Now, not only do we have a fancy name for it being outside the data set, but we have a fancy name for it being inside the data set as well, and that would be called interpolation. And so 900 would be considered interpolation, which is basically that the value is included in the data set. Now, it doesn't mean we saw 900 written in the set, but it means that it fits basically within there.
Okay.
And so this one specifically would have been. All right, so the big thing you're going to notice with this section is they always want you to interpret what it means in context. And you're probably like, yeah, that's what we've been doing for the last like so many chapters. Yeah, that's stats class. So, yet again, we're going to be interpreting what this slope means in context. So, there are two different ways you could write it. Either would be acceptable, so I'm going to write both for you so that you can see. Not everyone has like two that would work. This one, based on the fact that it's money, does work, and you'll see what I mean in just a second. So, the first option is for each additional (1 mile), okay, because distance is what we're changing. It's our explanatory variable. For each additional 1 mile of distance, airfare increases by 12 cents, okay? Because the 0.12 would be 12 cents. So that's one option. The other option is I could say for every additional 100 miles of distance, airfare increases by $12. Now, what I'm going to caution you is a lot of times people mix these two things together and they'll be like, for every mile it increases by $12. Like, no. And you can plug in numbers and see that. So, like, I literally just needed to plug in 1 for distance and it would show me that it's, 12 cents more than my y-intercept. If I plugged in 100 for distance, it's going to show me that it's $12 more than my y-intercept. So if you get confused, plug in a number and make sure it makes sense. Because for some reason, it doesn't seem like it should be difficult, but it seems to cause a problem. All right, so residuals. Basically, this is just a formula just to remind you. So a residual is equal to y minus y hat, which is the actual minus the predicted. So that's a formula you definitely need to know when quiz, test, whatever comes around. It's one of those that very well could show up on a concept questions page. So, All right, so we're not done with this problem yet. It keeps going on another page.
Nice.
Are y'all good on this one though, so I can take it away? What's up?
Hmm?
Just saying hi to it. Why not?
Smooches is learning a lot in this class period. He's paying
I-
very close
yeah,
attention.
I think Switches should take my AP test for me. I think you would do well.
Send the class pet in to take the test with you. Be like, is there a rule about a class pet being in the testing room?
Wouldn't it be in here?
Okay, so the actual airfare from Baltimore to Atlanta is $178. What is the residual value for Atlanta, and what does that mean in context? So, the downside did not have any other thing on the screen. There we go. So, this is what it actually cost the person to, let's say, book their flight. The predicted is not given to us. Wait. Yeah. Hold on. Yeah. This is the actual, this is what came out of the chart. Sorry. Trying to make sure I have this right. So we need to figure out what it should have been predicted to be based on our model. Now, obviously, our model came from all the values, but we want to see what it would be predicted to be, assuming that it was correct. So up here, just so that it's like out of the way, airfare hat is equal to 83.27 plus 0.12 times, and it was 576 miles from Baltimore to Atlanta. So I need to know what the predicted cost would have been.
$152.39.
So 152.39. So now, what is the residual value for Atlanta? So that's going to be actual minus predicted. So the residual is going to be actual was 178 minus, it would have been predicted to be 152.39. And so what does that give us?
$25.61.
$25.61. And then what does this mean in context? Basically, it tells us that the predicted airfare was too low. All right, so this next one, the residual for Chicago is negative 61.10. What is the actual airfare for Chicago, and what does it mean for the residual to be negative? So basically, this one's a little confusing because they give you an amount in the table, but we actually need to show like how to get there.
Oh.
So kind of pretend that it's not in the table.
Oh. I was about to just write what the table was.
The answer will be similar, but not exactly. So, and that's for this one. It may not always be that way, but So airfare hat is equal to 83.27 plus 0.12 times the distance is 612 miles. $156.71. So now basically we're solving for actual for Chicago. So I'm going to use the residual value of negative 61.10 is equal to, I'm going to actually write it as ACT for actual so that, you know, we get in the habit. But if you wrote it as Y, that would be fine. Minus 156.71. So basically, you just need to add the 156.71 to the negative 61.10. And so then our actual value would be $95.61. So, like I said, it was close to what it said, but we wanted to show how to find it if hypothetically they didn't tell us what it was. And so as far as what does it mean for the residual to be negative, basically a negative residual means the actual cost is less than the predicted, which probably just made sense to you, but to some people it doesn't, so always want to, you know, or it may not have initially, the thought may not have been there, but if you thought about it long enough, you probably would have figured that out.
Yeah. That was my assumption.
Okay, so then what is the correlation coefficient for the regression model for predicting airfare based on distance? So this, you get to go back to your linear regression, so you may just have to run it again, and it'll tell you what the R value is. And once you get that, don't clear it off your screen because we need something else on there. And just 2 decimal places for that as well. My suspicion is that it's longer than 2, but it might not be. Some of them work out nicely and others not so much.
Yeah.
What do we get?
0.79.
0.79. All right, so don't clear it because we need it for the next question as well. So the variable of the correlation coefficient, written R squared, measures the proportion of variability in the Y variable that is explained by the regression model with the X variable. This percentage measures how closely the points fall to the least squares line and also provides an indication of how confident we can be about the predictions made with the line. So what proportion of variability in airfares is explained by the regression model with distance?
Is that just asking what R2 is?
Yeah.
Okay. Because it made it sound a lot more complicated.
We're going to write about it, but yes.
Okay. What you doing? Oh, I forgot. I was like, I'm not in this class.
So what is R squared?
0.63.
0.63.
Yes.
So then what this would mean is that about 63% of the variability in the airfare can be explained by the regression model with the distance So then the last thing, and then we'll stop for today because when we're almost out of time, and the next question I think is like another 2-page question. So,
We've only had like 2 questions technically for like the whole example.
but I mean it includes like everything you need for the
Yeah.
entire section. It's just like
Yeah.
each problem has like all the parts.
We're going to H.
All right, so residual plot, this is what we basically drew in the notes, but, you know, just kind of all over the place. No, like, pattern to it or anything, and no, it doesn't matter that the dots are different sizes.
I was literally about to ask that. I was like, wait.
No, it just happens. Thank you, iPad.
I was like, it looks kind of cool. Polka dot.
So, if the plot of residuals versus the explanatory variable shows no pattern, a linear regression model is appropriate.